How do you define atomic size? According to Rutherford's model, an atom at its center has a nucleus and then it is surrounded by, according to Niels Bohr model, electrons are revolving in discrete orbits. So let this be K shell, let this be the L shell. This is the innermost shell, this is the outermost shell, and this is our nucleus where protons and neutrons are present. So an atomic size or atomic radius is defined as the distance from the center of the nucleus to the outermost shell. Next question is, how does the atomic size change as we move from left to right and as we go down the group? Let us discuss this. First, let us take group because it is very easy. Okay, so once again we will take group number 1. Group 1, hydrogen. Hydrogen has 1 electron, which means it will be going to the K shell, and this will be the atomic radius. Below hydrogen we have lithium. Lithium is 2,1, which means there are 2 shells. So this is my nucleus, this is my innermost K shell, and let us say this is my L shell. This is K and L. So this will be the atomic radius from the center to the outermost shell. Sodium 2,8,1. 2 electrons will go to K shell, the remaining 8 will go to L shell, and the outermost electron, the valence electron, will be in the M shell. So there are 3 shells. 2, 3. So 1, 2, 3. Therefore, this is the M shell. This will be the atomic radius. So it is quite evident that as we go down the group, atomic radius, atomic size will increase. Why? Because new shells are getting added. As new shells are added, distance from the center of the nucleus to the outermost shell will increase, which means atomic size is increasing. Very simple. So atomic size will increase in a group due to the addition of new shell. How does it change in the period? Let us take once again the second period. So lithium, as we know, it is 2,1. So this is my nucleus, K shell, L shell. Beryllium, atomic number is 4. So 2,2, which means there are 2 shells. In a period, elements of the same period will have same number of shells. Outside, it may appear that atomic size is same because only 2 shells are there, right? But it is not. In effect, atomic size will decrease as we go from left to right. In a period, atomic size will decrease. Why? Even though the number of shells is the same, this is because of a property called as effective nuclear charge. Effective nuclear charge. What is this nuclear charge? In the nucleus, we have protons and neutrons. Neutron does not have any charge, which means protons have plus charge. Therefore, the charge of the nucleus is nothing but positive charge. So, as we go from left to right, effective nuclear charge will increase. In this instance, lithium, beryllium, boron, carbon, fluorine, let us take. So lithium atomic number is 3. There are 3 protons and 3 electrons. Beryllium 4 protons and 4 electrons. 5 and 5. 6 protons, 6 electrons. 9 protons and 9 electrons. As we go from left to right, one extra proton is added. So how does this affect the size? Now, as the charge of the nucleus increases, we know unlike charges attract each other, right? So as the positive charge of the nucleus increases, it will attract the electrons more strongly. The electrons in the outermost shell are more strongly attracted. When compared to these two, here the pull will be less. The effective nuclear charge will be less because protons are less. As protons increases in between boron and carbon, carbon has 6 protons, boron has 5 protons. Because the positive charge on the nucleus is more, the pull will be more. So as the pull is more, it will pull it more closer, which means size will reduce. So as we go from left to right, atomic size will decrease because effective nuclear charge will increase. So important learning outcome here is the first element in the period will have the biggest size, because as we go from left to right, size will keep on decreasing because effective nuclear charge will keep on increasing. In a group, size will increase because new shells are added.